Let's review some of the ways that we learned to make alcohols in Organic Chemistry 1. One of the first ways that we learned how to make an alcohol was by a substitution reaction, whether it be an SN1 or an SN2, and of course that depends on the substrate. If we have a primary substrate, like 1-chloropropane that we have here, we can treat that with sodium hydroxide. Since it's primary, we just do an SN2 and we end up making 1-propanol. However, in the second example, we have a tertiary alcohol, and this is going to undergo an SN1 substitution to form an alcohol. In the first step, the leaving group leaves, and then the water can come in as a nucleophile to produce an oxonium ion, which can then be deprotonated to give you the alcohol. We sometimes refer to this as a solvation reaction. Now, if you're wondering, could I do this with a secondary alkyl halide? The answer is not really. An SN2 or an SN1 wouldn't be effective with a secondary substrate because SN1 conditions are going to be too slow for the substitution to occur, and SN2 conditions are mostly going to produce alkenes, so elimination products, instead of substitution products. We also learned how to add water across a double bond in Organic Chemistry 1. In Chapter 9, we learned that you can do the Markovnikov addition of water across an alkene using sulfuric acid, and instead of writing dilute H2SO4, you can also use dilute hydrochloric acid or other strong acids, and thus you can just write H3O plus for the Markovnikov addition. The next reaction is Oxymercuration Demercuration. It's a two-step reaction. In the first step, we treat the substrate with mercuric acid and water, and then in the second step, we do the demercuration with sodium borohydride. Now, this is also a Markovnikov addition of water. However, when we use oxymercuration demercuration is when we're trying to avoid a carbocation rearrangement. So we'll put that in there. We use that to avoid a carbocation rearrangement. And the last one is if we want to do an anti-Markovnikov addition of water, we use hydroboration oxidation. And so again, hydroboration oxidation is anti-Markovnikov, and the first two that are both acid catalyzed reactions, these two reactions, will both produce the Markovnikov products. Question 12.8 asks us to identify the reagents that you would use to accomplish these transformations. In A, we have a tertiary alkyl halide, and we want to make a tertiary alcohol. And so for that, we would need an SN1 reaction to occur, also known as solvation conditions. We would just use water, and that's all we need. Our leaving group leaves, the water comes in as a nucleophile to produce an oxonium, and then it gets deprotonated to form our tertiary alcohol. In the next one, we have a primary alkyl bromide, and we want to convert that to a primary alcohol. And so for that, since it's primary, we can just use sodium hydroxide, which will act as an effective, or the hydroxide is going to act as an effective nucleophile and give us the SN2 product. So let's pencil in the mechanisms here. This is SN1, and this one here is SN2. In the next one, we're doing a Markovnikov addition of water across the double bond. There is no concern about carbocation rearrangements, and so we can just use H3O plus, which you can form from dilute sulfuric acid or dilute hydrochloric acid. The next reaction is an anti-Markovnikov addition of water across the double bond. And so for that, in the first step, we're going to need borane and THF. And then in the second step, we're going to need hydrogen peroxide and sodium hydroxide. The last one is a Markovnikov addition of water across the double bond. However, if you were to just try to use dilute acid to do this reaction, you would end up producing this carbocation, which can undergo a carbocation rearrangement, namely a methyl shift, to give you a more stable carbocation, and I can draw that over here. You go from a secondary to a tertiary carbocation, and we want to avoid this carbocation rearrangement. So how do we do that? The way that we do that is by using the conditions of oxymercuration demercuration. The first step would be to treat the alkene with mercuric acetate in water, and then the second step is to treat it with sodium borohydride.